Hello everyone, very good morning and good evening. So we'll start the session, guys. Let me share my screen. Okay, so cool. So today, what we are going to do is we'll discuss about how to work with a partitioning concept. So here basically, in Snowflake, right? In other databases, we are going to think about partitioning, and then we can create indexes. We will improve the performance, right? We will create partitions. We will improve the performance. But here in Snowflake, we no need to create any partitions. There is no concept of creating indexes in Snowflake. So it is not in our control. So we cannot able to do that. And then even partition creation also, so we cannot able to do that. We cannot create a partitions. So for example, let me show you the some data here. Select star from. I will pick one table from this. Any table we will pick. The huge volume of the table. Let's see how much data we have. Very less. Okay, 770 GB data we have. This table we will pick. This is the table, and where from this catalog, let me preview the basic data here. Preview data. I will pick CR item SK value is this one. Okay, now observe this. How much data we have there in this particular table? We have around 14.4 billion rows, and at the same time 770 GB of the data we have there in this particular table, almost nearly 780 GB, 780 GB of the data. And normally, if you wanted to fetch any information from this particular table, this huge volume of the table, in other databases, how much time it is going to pick, how much it is maximum to maximum, minimum to maximum, in between 30 to 45 minutes it is going to take in any of the other databases. Now let's observe this. When I am running this query here, how much time it is going to take with extra small virtual warehouse. Only we are using extra small virtual warehouse. And if you observe here, see this, when the query is running, right, we can see the query execution plan, what exactly is happening in the backend. That we will call it as a profile view. If I click on query ID, this is the query ID for this, right? You can able to see in this query ID, see this one, we can see the query profile. Here in the query profile, we can able to understand, so what exactly is happening in the backend. So this one, so it is scanning the table, and then it is applying the filter condition, and then it will display the result, right? And at the same time, see this query is finished now. And when you observe this, you can see these two things. Observe this one, what it is telling. The query has taken 27 seconds. 27 seconds the query has taken, very less time. And at the same time, you can able to see partition scanned, 3,999 partitions it scanned. And how many number of total partitions we have? 49,448 partitions. It's approximately 49,500 partitions. Let's assume that. But did we created a partition for this table? No, right? Did you mention anywhere you need to scan only these partitions for this particular respective data? We didn't mention anything, right? But how come this Snowflake will understand, okay, these many partitions has been created in this table, and in this partition I need to scan only this partition instead of scanning the 49,448 partition. It scanned only 3,999 partitions, right? Now how it happened here? So what is the purpose of this? So here when it is coming to this, right, so basically what Snowflake is going to do is When the data is storing in the backend, data is going to store in the form of columnar storage. So what is going to be happen is, let me show you partitions. See this one. So if you observe this, you can able to see this. This is our logical structure. When I execute a query, I can able to see the data like this: ID, like type, name, country, date. We can see the data like this, right? So normally in other databases, it is going to store in the row format. So here the data is going to store in the columnar storage. It means each column, observe the column type, it is going to be stored into multiple partitions. Column type, the six values, it is storing in partition 1, first 6 values. Next 6 values is stored in partition 2. Next 6 it's stored in partition 3. Next 6 it stored in partition 4. Observe this one. Type column, it is stored in all the 4 different partitions. Same way, when you're coming to the name column, if you observe this here, again it's stored into 4 different partitions. So every partition, you will have data for every column. Now if you observe this, country, again it's stored into all the partitions. Date column also it's stored into every partition. When it is storing the data in the backend in the partitions, what is the advantage here? This we will call it as a columnar storage. Each and every column value, it is going to store in the form of row format. So this we will call it as columnar storage. Now here, when you observe partition 1, for example, we required the data. We are going to fetch the data for type 4, name C, country SP, and then the date is this one. When you need this data, if you observe this, where this particular data is available, in which partition the data is available here. Observe this one, the data which it is available in the partition 1, right? 4C and then SP 11.2, that is available in only in partition 1. It is not available in partition 2, partition 3, partition 4. So that it only fetch information from partition 1 only. Instead of going to the other partitions, it will fetch from the only partition 1. Let's say this other combination, this 3, this X, DE 11.5. This data, where in which partition the data is available, if you observe, that is available in partition 4. So that when the data is fetching from the table, instead of scanning the complete partitions, it will go and then hit exact partition. And one more thing here, maybe the data is available in same combination, may be available in multiple partition. And at the same time, how come this Snowflake understand which partition the data is available, which partition it has to scan? What will happen is, every partition when it is storing in the backend, right, it is going to store in the form of micro partitions, and every micro partition, these all micro partitions, it will have range of values. It will have range of values. Now if you observe, see this one. So this is normal how the data is going to be stored in the row level format, and then this is columnar storage format. This is columnar storage. And when you come to see this, every partition, this is a partition 1, this is partition 2, micro partitions. Observe this one. Here, when it is coming to the micro partition 1, it will manage metadata of this partition into, see this, cloud services layer. Partition 1 metadata, it will be available in cloud services layer of this particular micro partition. Metadata means what it will do is, it will have the information about this data in metadata. It means every column, minimum and maximum, will be stored in the metadata information. Not only this, the table information, size information, and the nulls information, everything will be stored in the metadata in the cloud services layer for every partition. That's the reason if you see, just if you move the cursor on the table, you can able to understand, see this statistics, like how many rows we have, what is the size, and then when it has been created, all this information we can able to see. Instead of writing a query directly, we can able to see how many number of rows here, what is the size, right? So this we are getting it from the metadata information. So here the same thing, every partition, how many partition the Snowflake is going to create, every partition, these partitions metadata will be maintained in the cloud services layer. From here, so it will understand, okay, if I have 5,000 partitions or 50,000 partition, in these many partitions, which partition metadata my requested data is available. Based on that, here itself it will understand, okay, these many partitions only it has to scan based on this range of values. For example, here if you observe, I want ID1. Say this one, in this example, ID1. Which partition ID1 is available? See this. Is it available in metadata 2? No. Where it is available? Metadata 1. Metadata 1 belongs to partition 1. So it will fetch only the partition. It will not go to the partition 2. For example, if the data is required, like related to ID 10. 10 is available here, 10 is available here also. So that what it will do, it will go and then fetch the information of the both the partition, it is going to check. So whether the data is available in the both the partitions or not, it will scan, right? The same way, for example, so if you like observe here, like a value 12, ID 12, it is not available here, only it is available here. So it will pick only the partition, this one. Like that, Snowflake is going to understand which partition it has to scan. Now, if you come to this every metadata information, what it contains, observe this one. It contains information related to the table level. See this one, the table level information, the row count, the size, and then so file refer to that particular table version. And at the same time, number of values, minimum value, maximum value, null count, all these things will be available in the metadata. Based on this, when the partition is creating, it is going to have this information here in the metadata information. And this information based on this, so Snowflake will understand. Now see this information will be available in metadata. And at the same time, when you come to micro partition on this topic, you will get a certification question. See this, every micro partitions are immutable. We will come to that, what it means by that. It means once the partition is created, we cannot able to modify the partition. We cannot able to modify, we cannot able to change the partition. But how come updates will happen in Snowflake? We will come to that. Now when it is coming to this, the data, say this one, what Snowflake is going to do is, it will automatically create the partition based on ingestion order. You don't have any control when the data, when the Snowflake is creating partition. So as a user, we don't have any control. Automatically, Snowflake is going to create partitions when the data is inserting into the table. And at the same time here, if you observe every partition, right? This is your certification question. Maximum compressed size will be 16 MB. Every partition, 16 MB of the compressed data, it will be available. And at the same time, 50 to 500 MB uncompressed data, it will be there in the every micro partition. The every micro partition, it will have 16 MB of the compressed data, and then 50 to 500 MB of the uncompressed data. It is available in every partition. Now, when it is coming to these partitions, we will say that it is immutable. It means Once the partition is created, you cannot able to do any changes for the partition. Then how come the updates and delete will happen? So what is going to be happen is in the back end, let me show you. We'll discuss on that. This is the like a partitions in traditional databases, but here the Snowflake will not have any partitions. Snowflake will not use any like keys to create a partitions automatically based on the range. It will create it. This is the statistics which we saw that. What will happen is here. Let me show you why we are telling that micro partitions are immutable. Once it is created, you don't have any option to create a partitions. This is very important. Let's like understand it carefully. Observe this. Let's say we have this data. Okay. Here, this created into three partitions. Let's assume that partition 1, partition 2, partition 3. For example, if you come here, see this one. These are the 6 rows. It's created into two partitions, partition 1, partition 2. What is the mechanism it will follow when it is creating a partition? We will see that. But they said that just they are following some algorithm, but they didn't relieve how they are creating a partitions in the backend. Now only the thing is we have to understand. So based on their whatever the documentation they have given, so we have to understand so how this is working. Now these partitions, if you observe, it's created two partitions, guys. The 3 rows here in the one partition, 3 rows here in the two partition. Now today it happened. Let's assume that. Now maybe tomorrow I'm going to insert some data, some 2 to 3 rows. Then it will create new partition as P3. Suppose let's assume that P2 partition still we have space. No, it won't disturb the P2 partition. If once the partition is created, so once it is committed, so we cannot disturb the P2 partition. So automatically it will create a partition P3. Partition P3 will be created. It means any insert, any delete, whatever it may be, P1 and P2 partition will be still it will be available. If you are doing some changes to this P1 and P2, then what will happen is this P1 and P2 will go back as a versioning till our time travel, how many days we are having. On top of that, new partition will come into the picture. It means, let's assume this. For example, we are inserting a new value. See this, P3 partition is created. P1, P2, P3, three partition is available. Now, let's say here in the partition P1, we wanted to delete this ID 3. We want to delete ID 3 here. When you wanted to delete ID 3, where it is available, which partition the ID 3 is available, P1, right? What will happen is it won't disturb P1 based on that particular time. When we wanted to delete this, P1 will go to backend as a versioning. It will be maintained with that particular timestamp in the backend. It is going to maintain till how many days you have retention period, those many days it will maintain. In place of P1, P4 will come. The P4 will have 1 and 2. P1 will have 1, 2, 3. That will be in the backend. Now the new partition P4 will have 1 and 2. It means old partition will be moved to the backend and then P4 will come into the picture for the delete. So if you observe this, see this, it will happen like this. Only when you are fetching the data from the table, you can see only P4, P2 and P3 only. If you use time travel, then you can able to get it from P1 also, because the P1 partition will be in the backend with a timestamp. But when you fetch the data, always it will point out to newest partitions, so which it is available P4, P2 and P3. Now let's assume you have any update for any one thing. What will happen? This one will be updated, but for example, P4 will go to backend. For example, ID2, I'm updating as ID9. Now P5 will come into the picture. P4 will go to the backend as a versioning. That's the reason if you observe when you discussed this CDC concept, capture data change with the help of streams, the old partition, the data has been deleted, new partition will come into the picture. For every update, you can see two entries. One is delete entry, another one is insert entry, because what will happen is in the back end, that partition will be completely like moved into the back end. That's why it will say it's a delete, and then the entry that will come into the picture as a new partition, right? So like that, so partitions is going to work in the backend. Here we don't have any control on it. So even though if you have a space in P3, now we can see P3 7 is there. But when we are inserting the new data again, once the partition is created, now next day I'm trying to insert new data into the table. Partition P3 is have a space, but these partitions are immutable, right? You cannot able to change anything. So it will go to the backend. P3 it will be there. P3, P2, P4 now we have. Now new partition will be created as a P5. Like that, the data will be like partitions will be created in the backend. Okay, this is fine. But how come these partitions will be created? Till how many levels these partitions, this like a distribution will happen? So what will happen is when you are storing the data into the table, when we are loading the data into the table, Snowflake is going to run algorithm in the backend to create the partitions. It has to distribute, right? Here, if you observe, it has distributed the data into this around 770 GB data. It has distributed into 50, nearly 49,448 partitions. It has distributed the data. How come the Snowflake understand this distribution will happen? So where it has to stop? How many distribution is required, right? These things, what it is going to do is, when you come here, let me show you. This is what it will happen in the backend. See this. What will happen is whenever the data arrives into the table, it will split the table files into the levels that we will call it as a clustering state. It will split the table files into multiple levels that we are going to call it as a clustering state. And at the same time, this clustering partition algorithm is going to run in the backend, but they didn't relieve us like how this will happen. They're telling that algorithm they are running on the each level, and then until it looks the clustering depth is good enough, it will keep on running the partition algorithm, and then it will distribute the data and it will create a partitions. It means, let me show you here. Let's observe this one. Okay, before that, let me show you other diagram. Okay, let's observe this one. See this. This is what will happen is this is the level 0. Now, whenever the data comes, so the data is available like this, it is started the creating a partitions. When it is dividing into the width levels, see this one, this is the first one, 0. When it is coming to the level 1, see this, when it is coming to the one level to the next level, what is happening is it will reduce the clustering width, and at the same time it will become more partitions. This should not have any overlap. Observe this one, level 3. Do you have any overlap of the partitions? No, right? But when you observe the level 2, we have a overlap. When you observe the level 1, you have a overlap. When you observe the level 0, we have overlap. What will happen is this overlap has to come to 0, and it should not have any overlap till this level. it will keep on creating partitions. Once it's reached this level, it will stop creating partitions. Now, if you observe here, the example of this particular data, see this one. Let's assume we have the values A to Z. Now, these values from A to D, E to Z, and then it's divided A to Z into 5 partitions. All are in one place only. So this one by one on top of one, it has been occupied. It means in the single space, it is occupying everything. It is overlapping, right? If you have a overlap, then identifying the partitions metadata, it is very difficult. What it is going to do is, it is going to distribute like this. So this one, it should not have any overlap. Overlapping should not be there. This is level 0, this is level 1, level 2, level 3. When you observe the level 3, see this one, A to D, A to D values is here in this partition, E to Z values in this partition, and then K to N is in this partition, and then this 0 to S in this partition, T to Z in this partition. When you observe the next level here, if you observe, there is a overlap. And one more thing is overlap depth, overlapping micro partitions. Overlap depth should be 1. Overlapping micro partition should be 0. Overlap depth means if you observe this black line, this horizontal line, when you observe this one, see this is only 1, that is overlap depth. This is 2, that is overlap depth. Here in the black line, how many is occupying? 3, 5. But when you observe overlapping means, see this here. This is 1, here this one, this is overlap, and this overlap. Total overlap is 3. That's why you can see that 3. Here the overlap also 3. Here the overlap is 5. So the main intention of that algorithm, what it is going to do is, till this level it reaches, it will keep on create partitions. Once it reaches this level, it will stop this algorithm, and then it is going to like store this partitions metadata in the cloud services layer, so that when you are fetching the information, see this, if you have like this, now I want the information of D. In which partition D is available? Partition 1. Did it has to scan the complete table? Not required, right? For example, I need information about I. Which partition the I will be available, right? Only that partition. It will go and then it will fetch the information. It will not scan the complete table. Normally, what will happen when you are fetching the data in traditional databases, it is going to scan the complete table for that particular required data. But here is no need to scan the complete partitions. It is going to scan the exact partition, and then it will fetch the information from there, right? So that's the main intention of these partitions, how it is going to be created. And at the same time, here we have a concept of clustering mechanism. Here if you observe one thing, see this here, in the where condition I mentioned only CR item SK column. Why I have mentioned only this particular column? Now if you observe this particular table, see this clustering key. What we have, the clustering key, there is 2 columns. One is CR item SK, another one is return date. Based on these columns, clustering key has been created. Here when you have a clustering key on a table, when you use that clustering key column in a where condition or select list, your data fetch, it will be little faster. So when you are fetching the information based on this clustering key column, it will be little faster, because what will happen is when you mention any clustering key column, it is going to sort the data in the backend. For example, here when you have this partitions, right? See this here, when you create a clustering key, which column we preferred on a clustering key, based on that column, your metadata will be maintained and it will be in a sorted order. Here is the data is in a sorted order now, right? 1 to 12 and then 2 to 10 we have here. There is no sorted order here. What it is going to do is it will keep the data in a sorted order. So for the metadata information, readily it will be available. So that exactly it will understand. So which partition it is available when it is fetching the information, it's going to understand. This particular concept, fetching the information from exact partitions instead of scanning the complete table, this particular thing, right? We will call that as a pruning technique. We will call that as a pruning technique. So fetching the information of exact partition in total number of partition, we will call it as pruning, P-R-U-N-I-N-G. So remember this one. So here, based on this concept, so this clustering key is going to be created. Here, when you are, this clustering key creation only is in our hand. We can create it on our own. But in some of the projects, some of the organization, this will be restricted. We won't use this clustering key concept. Basically, what will happen is when you use a clustering key implementation, it will be computationally expensive. So we won't use it. So to avoid unnecessary cost, we are going to avoid clustering key concept. But if you really required, and one more thing, we cannot create this clustering key on frequently when the data is updating in the table. You cannot able to create a clustering key. You should not create it, because whenever you are inserting the data into the table, if you have a clustering key column, what will happen is based on this key column, your data has to be rearranged in the complete the table, so that every time when it is sorting out the data in the metadata information, every time it has to restart from the scratch. That's the reason if the table is frequent update on a table, you won't create a clustering key. And at the same time, so when you are fetching the information, so very rarely you no need to create a clustering key. Very frequently when you are fetching the information, there is less updates on the table, less inserts on the table, then only we are going to use the clustering key. When you use a clustering key, one more thing, this is also another certification question. When you are using clustering key, we can use a clustering key is one with the combination of maximum 3 columns. You cannot go beyond that. Maximum 3 columns only we can create it on clustering key. For example, here, see this, you can see the 2 columns, right? But key is one, clustering key is one, but the combination is 2 columns. So like that, based on the, one more thing, clustering key creation, always we need to pick numeric columns or date columns. It should be the column which you are picking for the clustering key. It should be more distinct values. It should not have any duplicate values. That's why most of the time we will create it on a date column or any of the unique column. We are going to create a clustering key, so that when you create it, what will happen, whatever the partition it is going to create in the metadata, micro partitions metadata information, based on the key column, it will rearrange the data in a micro partitions metadata information, so that it will improve the performance. That's a main thing. So why this clustering key is going to work. And at the same time, when it is coming to this, let's say, nothing, let me show you. See this one. When the query is running very slower than the expected, so then only we have to use this clustering key. And if you see the note, clustering can be computationally expensive. We should not use it. If you wanted to create a clustering key, but for example here, whatever the tables we created here, so these tables, we didn't created any clustering key in our tables, right? So just we created a table, but we didn't created any clustering key for our tables. If you see it here, see this one, all the tables, the whatever we have created, these tables, all the tables, it's a like a table, but there is no clustering key, right? If you wanted to create a clustering key, whenever we created a table, during that time we can create a clustering key. Other option is, once the table is created, later also you can add a clustering key. Both the options is there, but most of the time, 95% of the time, we will avoid creating a clustering keys. Now if you wanted to create it, let me show you so how we can able to do that. For example, say this is a simple command. Generally when we are creating the data, when we are creating a table structure, we will use create table, table name, right? And then we will use these are the columns, column and data type, right? Till here we will use it. Now when you observe this, here we are using cluster by. See this one. Additionally, we are using cluster by column, cluster by, and which all the columns we need a clustering key. Just if I run this command, the clustering key will be created for this particular T1 table. Now if you see this one, the clustering key is created for this particular column, right? C1 and C2, two clustering keys two columns combination we created a single clustering key. We cannot create multiple clustering keys, but we can give the combination of columns. Now at the same time, so when it is coming to this, for example, already the table is created. So we have a EMP table, right? So we have a table. Let me come to this. We have a table. This table is already available. For this table, I wanted to create a clustering key for a employee ID column. Yes, we can able to do that. Then, so we will use alter table, table name, add clustering key. Let me copy the command. It's very simple. This is for the dropping. Alter table, table name I will use EMP. Cluster by, for example, what is the column here? Employee ID will take. EMP ID will take. Observe this one. So we are altering the table and then we are creating a cluster by column for this particular employee ID column. Now observe this, what will happen here now? Now we created a cluster by column for the employee ID. Now for this table, when you observe, see this one, employee ID column. Now what will happen here in the back end? So it is going to micro partitions, whatever the micro partition it is going to, it is very small table, only you can able to see one partition only. And then in that metadata will be maintained based on this employee ID column. It is going to sort the data and then it will keep the values in the backend. All these things will happen in the backend, so you no need to like worry about it. We don't have a concept of indexes here. There is no concept of indexes in Snowflake. You cannot able to create it, and at the same time you don't have any control on creating your partitions. You cannot able to create a partitions. Only the thing is you can create clustering key, but there is no possibility of creating a partitions. Okay, so remember this one. That's the reason always the Snowflake is going to to give the best performance because of this micro partition, because of this storage, how the data is storing in the backend in the columnar storage. And then the partitions are immutable, right? Whenever you are doing some changes for the partitions, backend, that partition will be maintained as a versioning till how many days you have retention period. The new year partition will come into the picture. So when you fetch the data, always it will be hit the newer partition. If you wanted to fetch the information from the backend like a time travel, then you have to use time travel command. Then it will fetch the information from the backend based on the timestamp information. This is how this is going to work. And at the same time, cloning also the same reason. When you use a cloning also, this is all because of the partitions, right? Partitions will be there in the backend. These partitions will be shared. That's it. So you cannot able to disturb the original table micro partitions. It is sharing to us. And then when it is creating, for example, clone table, now you are creating a new, you are inserting the new data. What will happen? New partitions will be created. That belongs to the clone table only, right? So this is the concept of like how the partitions is creating and then how it is going to work it. And what we will do is in the coming session we will see the integration to AWS and then how to work with AWS and then how we are going to pull the data from AWS and then how we can communicate AWS and Snowflake. We will try to load the data from AWS files and then we will see that creating storage integration object, working with the different files like JSON files, Parquet files, semi-structured files. Once the data is loaded, so if you wanted to automate it, so how to automate this process like continuous ingestion process. Generally here what you are going to do is we are running copy command manually, right? So but in real time when you wanted to work with any, when you are working with any project, it should not be the copy command. Like manually we won't run it, no one will run manually, right? So if you wanted to load it, so then we have a concept of continuous ingestion process with the help of Snowpipe. All those concepts we will see. So when we are covering with the AWS, don't worry about the AWS knowledge. You no need, right? And don't worry about that. No need of the much knowledge on AWS. I will explain you what all the things it is required. Just you required, just we need to understand what is S3 and then what is IAM. That is more than enough for us. And then we are not going to do anything with the AWS also. Just we are going to access and then we will see that. That's it. Okay, in our project, so you will have a separate team, so we are going to interact with them. We will discuss that. And if you want anyone create account also, I will give you the like a step-by-step approach how to create a free trial account. You can able to create it. We will see those things in the coming session. Now let's come to the questions in this particular topic. You can see some of the questions. Definitely, the loading time also it will increase. That's the reason we are going to tell Kalyani, when you create a clustering key, it is computationally expensive. And at the same time, every time when you change the data, when you insert the data, when you update the data, again this clustering key is going to recreate it. I mean resort it. So that's the reason. What happens to the old partition for which data is modified? New partition created after retention period. Old partitions it will be still available till the retention period is available, Funny. So after the retention period, if it is available, those partitions will not be available anyway. The new partitions will be available in our uh, storage, right? So always it will point out to the new partitions. Old part in between the retention period, always it will travel, right? For example, we have 5 days retention period. You are doing some changes during these 5 days, whatever the things. So from the last 5 days, those partition data it will be available in a like a retention period, those many days. Like for example, 1 week before you have done some changes, those partition data it will not be available. Only the recent, like how many days of the retention period we have, those many partitions it will be available. Clustering key seems to be using most of the concept of indexing, pruning, sorting of the column. Not required, Ankit here. So when you are implementing this clustering key concept, right? So here it is not going to be implemented. And when it is coming to the indexing concept, right, that is nothing but our metadata. Uh, every partition it is going to maintain metadata information, right, minimum and maximum values. Based on that, the same concept, metadata concept, we can equal to indexing concept.
One thing.
One second, Kalyani.
Yeah.
Yeah, using less frequently used columns for clustering, etc. No, for clustering key column, always we have to use more frequently used columns only. Okay, so because when we are fetching the information, which particular key column we are specifying, so it is going to hit those particular column only, right? And then at the same time, when it is hitting the metadata also based on this key column, it will fetch very fast. That's the reason very frequently utilized column only we have to use. It will not maintain any separate structure. No, it is stored in the metadata partition only. It will not disturb the structure of the partitions when it is creating. It will maintain metadata information. It is going to be sorted in a sorted order. That's it. That's the reason the clustering will work. Yes, Kalyan, you are asking something.
Um, Where does the metadata stored? Means where is that exactly metadata stored?
Yeah.
That
All good.
when we run a query, you're saying first it will hit the metadata and then goes to the
Mm,
particular
mm,
partition and hit that,
mm,
right?
mm,
So
mm,
where we can see, is it exposed or is it internal
mm.
to?
It is internal only. So what will happen is we will have a like a cloud services layer, right? So when it is coming to the cloud services layer, it is going to fetch the information from the cloud services layer first. So there your complete metadata it will be available. So let me show you just a minute. You will have I can see one second. Yes, I will open the architecture diagram. Yeah. So you can see this right here. So these are the three layers it is available, right? So here the first layer, that is cloud services layer. This one is the cloud services layer. So it here the metadata it will be available for every partition. But where the partition will be stored, this will be stored in our storage layer. Where the storage it will be available, which platform you are going to choose. For example, if you choose AWS platform, it will be in a AWS. If you choose Azure platform, that will be in a Azure platform. And then which platform it is providing the services, there the metadata it will be available in the cloud services layer.
Oh,
Clear, right? Yeah, can see other question. Does micropartition hold only 6 rows of the data? It configured like more or less rows of the data. No, Shravan, just the example we have taken this one. It is not like always the 6 rows of the data. It depends. So it will be approximately 16 MB of the compressor data. Okay. So it is not like every time it will be 6. And we cannot able to configure. That is not possible. That is not in our control. So it maximum it is going to be 16 MB. If the 16 MB of the storage is occupied after the compression, it will immediately it will create a new partition. The micro partition exists only depend on the data overlap. Yes. So if there is no overlap, then it will stop the micro partition. So if there is a overlap, it will create a new micro partition.
Doesn't it become too many partition for Snowflake to maintain because after 500 MB we are creating a new partition every time?
Yeah. So it will be like very what they are doing is they are distributing the data into more the partitions,
Mm,
and then they are maintaining everything in the backend.
metadata.
Yeah, so that is mandatory. So otherwise, it is very difficult to fetch the info. That's the reason it is hitting very fast, and then we are getting the data very fast.
And metadata is the key here, right? If that
Exactly.
is lost, nothing, we cannot.
It will be available for every partition. Metadata it will be available by default.
Can we have a look at the metadata alone, like what is being stored in the partition somehow?
No, so we cannot see the partition data. We cannot see where the partition is storing, and we don't have
Uh,
access to the metadata also. It's internally they are managing.
In
because
mine, we have meta store,
Yeah.
but here we will not be exposed to that meta store.
Yes, exactly. If they given that information, everyone can able to copy the Snowflake. Yeah,
yeah, that they're not showing it.
yeah,
Usually, I mean, partition gives a lot of
exactly.
benefits to the developers as well as DBAs to fine
Mm,
tune the things, but then
yeah.
they're not exposing it here.
Yes,
Then we are not able to leverage the partition
yes. That's the
benefits.
reason we don't have any control on it. So most of
Yeah.
the time they have given whatever the partition we are going to do it, right? In other databases. Here they are doing on their own, and then they are making it available so to fetch the information very fast.
Okay.
Yeah. Any other questions?
There is one question from your diagram which you were showing earlier, like how the depth is defined. Can you
Mm,
please bring that up?
yeah, sure. How does the snowflake know? One second, Ankit. Before
Yeah,
that,
sure.
Mohan is asking, how does the snowflake knows when don't create a cluster key and a table on what basis snowflake create micro partition cluster key? Yeah. So when it is coming to this question, Mohan, so when we are creating clustering key, right? Snowflake will not create any like a clustering key column. So we have to define. So here what we have done, we created a clustering key for the table. If the performance is very low for any of the table, if you wanted to still improve the performance, then we can create a clustering key like this one. The clustering algorithm is different. Clustering key is different. Here what you are seeing, this is a clustering key, right? And then when the Snowflake is creating a partitions, that we will call it as a clustering algorithm. That is different. This one is different. If you want to improve the performance even still, so then we can create a clustering key option based on the like key column which you are going to use it very frequently. But so the question so which you have asked is that is a clustering algorithm, what it is going to do it in the backend. Yes, Ankit, one second. Let me show this. This one.
Yeah,
Yeah.
yeah, this one. So the third row, right? The
Okay.
overlapping micro partition says
Mm,
3.
mm.
Is it like the
Yeah.
total
This
number of?
this one. See this. Here these two are overlapping, right? Here. These two.
Okay,
This one here in this space and this space. This is overlapping. Here
okay,
this and this overlapping. So totally it will be 3. That's the reason totally it
okay,
will be
okay.
3.
Got it.
Yeah. Any other questions? Okay, guys. Thank you. See you tomorrow. Thank you all. Thanks for your time.